Today's lesson follows on from our first Year 13 maths lesson, in which we introduced the idea of radians as an alternative way of measuring angles. So what we're going on to today is to find arc lengths, but when the angle is measured in radians. So within our sequence of lessons that we're looking at, remember this is all chapter 5 in the blue Year 2 textbook for maths. So we did about degrees, radians, converting between them. And what we're going on to today is finding an arc length using radians, and then next lesson we'll be looking at areas of sectors and segments. So you should remember from GCSE work about how you find an arc length. So we're going to have a look at what difference it makes when the angle is actually measured in radians. And what you'll see is it actually makes your life easier. Okay, so you want to be writing notes down, so make a quick sketch of that diagram. So here we've got a circle, radius r, and we've got an angle at the centre, theta. Now, when you split a circle like this, okay, it gives you an arc, okay. Now, just a bit of terminology that you might or might not be aware of, because I've just worked through the questions you're going to do at the end of this lesson. Just in case you weren't aware, when you split the circle circumference into two pieces, this arc here, okay, would be called the minor arc because it's the smaller one, and this one here is called the major arc, okay. It just comes up in one of the questions that you're going to be doing a bit later. So just in case you weren't aware of that, I thought I'd mention it. Okay, right, think back to your GCSE work, how you would find the length of that minor arc. Remember, it's a fraction of the whole circumference. So you would do theta over 360 because we're in degrees at the moment. So it's theta degrees, the whole circle's 360, and it's that fraction of, remember, this is the whole circumference. So it's that fraction of the whole circumference. Okay, so you should remember that from your GCSE work. Let's have a look at what happens then if we put theta in radians. Okay, so in our formula then, okay, you've got theta in radians. Instead of 360, we put 2 pi, because remember 2 pi is in radians, equivalent to 360 degrees. Times 2 pi r, the 2 pi's cancel, and you actually just get r theta. How nice is that? So if theta is measured in radians, then the arc length, remember this is the minor arc length, so it's the arc length that's made, or the arc length that's made by theta, actually. If you did make theta the bit round there, okay, then it would find that major arc length, all right? So it's the arc length made by the angle theta is r theta. Now you need to learn this, okay? It's not given to you, all right? So it's something that you do need to remember. So you see, it actually makes your life a lot easier, because I think r theta is easier than this formula that you would use for degrees. Okay, so that's the new bit of learning. So let's apply it to some questions. So here's example number 1. So pause the video if you need to, but I would like you to write down the question and draw the quick sketch that's been provided for you. Okay, now if there isn't a sketch given, then you draw one yourself. You can see all the information is in the words. I do generally always read through the words, because sometimes there's an extra bit of information in the words that isn't in the diagram. But if you have a look at this example, they've marked on the radius as 7, they've marked on the arc length as 2.45, and they said find the angle AOB, and they've called that theta. Okay, so we're going to show some good working here. So the first thing, the formula we're going to use, okay, so the arc length AB, the formula is r theta. So let's just state that, because that shows what we're using. So let's plug our values in then. The arc length AB is 2.45, r is 7, and theta is what we want to find out. So let's show our working nice and clearly. Final step then, theta is 2.45 divided by 7. You pop that into your calculator. Okay, refer back to the question, see if it mentions anything about accuracy. Okay, so it's important that you do specify it to the accuracy that they want. Well, actually, that does come out quite nicely to a terminating decimal, 0.35. Now, do remember your units. Remember in the book, they tend to put rad. I prefer just to put my little c there, which tells me that that's radians as well. You can say rad if you want. Either is acceptable. Okay, nice easy one to start with. Do remember to put your units on. Right, let's go on to the next one. Example number 2. Okay, so pause it if you need a moment to write that down. Okay, so for this particular question, not drawn you a sketch, so I would always, and you'll see in my working for all of my questions, I've always drawn a sketch, okay, just to help me, something that I can reference and look at. I find that easier than looking at lots of words. So here's my sketch. Okay, so it's an arc length AB, centre O, radius R, subtends. Okay, so that means, what subtends mean? If you've not come across that word before, that means that the arc, if you draw it back to the centre, it makes that angle theta, and the perimeter of the sector is P. Now, do be careful here. Perimeter means all the way round the whole sector. So if I was to mark the perimeter, I would need this bit, I would need this bit, and I would need this bit. So do make sure you're careful that when you have a perimeter, it's all the way round. Okay, so P, oh, I'm still red, that's fine. The perimeter is going to equal, well, I've got 2 straight bits, and then I've got my length AB. Okay, now it's fine to say R plus R is 2R. Now remember AB, theta measured in radians. There you go, tells you theta's measured in radians. So the arc length is given by R theta. Now what is the question asking you for? It's saying express R in terms of P and theta. So I need to get this equation as R equals something. So what I'm going to do first then, take out R as a factor on that side. So just a bit of algebra now. And they want R equals, so I'll write R equals P over 2 plus theta. Make sure when you're writing fractions, do a nice horizontal line there. Don't write it like this. Okay, problem with writing it like that is you don't know whether it's over the 2 or over 2 plus theta. So not that, nice horizontal line. That's your answer. Okay, right. Let's go on to the next one, getting more complicated. Example number 3. You'll need to just pause this for a minute to draw that down. Just a quick sketch, marking on the things that you know. Read again the words to see if there's anything that's not including in the diagram. It says the border of a garden pond is a straight edge AB. So you can see that's the straight part. So AB there is a chord of the circle. Okay. And a curved part C, and the curved part is an arc of centre O and radius 2, and it says find the length of C. So you can see on my diagram, they've marked an angle theta. If I can find that angle theta, then I can find the length of C. Okay, now the issue we've got here is we don't know what the size of this angle is here. Okay, but it's a triangle and we can work it out. Now let me just draw a slightly bigger version of it here so we can see. That's a little bit rubbish, but we can see what's going on. So this is my OAB. Okay, this is 2, this is 2. So that makes this an isosceles triangle. Now the easiest way, we could use cosine rule if we wanted, okay, to work out this angle here. But the easiest way to do it, because it's isosceles, is to split it down the middle, like that. Because it's isosceles, we know that the base will be split in 2. And then we can use a bit of trig to work out that angle there. Okay, and because these 2 triangles are the same, okay, we know that each of these halves is going to be alpha over 2. So let's use my trig then. Now, what do I know? I know the opposite one to alpha over 2 and the hypotenuse, so I'm going to be using sine. So sine of, that is 2 there, just make sure you read that. Sine of alpha over 2, opposite, over hypotenuse. Okay, so if I want to find what the angle is, remember you use your arc sign. 1.2 divided by 2 is 0.6. Over to your calculator. Do make sure you're in radians mode. Okay, you've got the little r at the top. Pop that into my calculator. I get 0.6435. I'll write ... because basically in my working, I'm going to be using all of that value. I don't want to round things too much because it can give me errors then. Okay, so alpha equals 2 times 0.6435 ... Okay, and that is 1.287. Again, I'll put ... and I'll put a little c because that's radians. So I've left that value in my calculator because I'm going to be making use of it. Now let's have a look back at our diagram here. So this is my alpha that I've just worked out, and I want to work out what theta is. So theta is the bit that goes round here, okay, that makes the major arc there. So how are they linked to each other? Well, they're all on a full turn, so they're all on 360 degrees, not working in degrees, working in radians, though they're all on 2 pi radians. So if I want to work out what theta is, I do 2 pi radians, take away the alpha I worked out, and again, put that in your calculator. Okay, 2 pi minus answer, which you've left in there, and you get 4.996, ... leave it in your calculator, radians. Okay, we're almost there. We want to find the length C. So the length C is an arc length, formula r theta, stated it. Okay, now what's my r? Back to my circle, my r is 2, so it's 2 times my theta, which is 4.996, ... So that's still in my calculator, so just do 2 times your answer, and you get 9.99, and you get some other stuff. Back to my question, does it ask for any accuracy? No, so 3 significant figures is good if it doesn't specify anything else. Okay, notice I've stuck my units on. Do remember some units. All of these are in meters, hence my arc length will be in meters. Okay, so make sure you've got that all written down. Do remember things like this, sort of thing you do at GCSE really, so do remember things like that. If you've got an isosceles triangle, you can use the cosine rule, but it's by far easier to just split it down the middle and use trig. Okay, final example. Now this is an example of an exam style question. Okay, I would like you to draw that out into your notes. You can see it's worth 8 marks, so that's quite a lot of marks on your exam. Okay, so you have a look at what we've got drawn there. There's a bit of context behind it as well. It's designed for the shape of an earring. Examiners like these questions that are in context. All right, they like to ask you something that has a bit of meaning behind it. So they've marked all the measurements on there. I'm just reading through the words. It says X, Y, and XZ are equal in length, so it's a symmetrical shape there. Okay, and the curve YZ is an arc, okay, of a circle. All right, and the angle of that arc that makes that arc is 1.1 radians. Okay, and it also tells you that X to O is 15 millimeters, which is marked on there, and the radius of the circle there is 5 millimeters. So all of the information is marked on my diagram. Okay, always worth checking though. So let's have a look at the first part. Find the size of angle XOZ. So let's spot XOZ. Remember, you go from X to O to Z. So we're talking this angle here. Now there's a clue in the question. It said that XZ and XY are equal in length. So this is a symmetrical shape. So the angle I've marked on there and this angle here are going to be the same. So we can work those out by remembering a full turn is 2 pi radians. Okay, so how we're going to get XOZ angle, can either do that or what they did there, is going to be 2 pi, take away the part that's already made by the circle, which is your 1.1. That's going to make both of those, so we need to divide it by 2. Okay, and that is 2.59 for this particular question. They've asked you to specify to 3 significant figures. Okay. All right, but I have sort of put that in my calculator. I've left that in my calculator. Okay, so I can use that a bit later. Let's have a look at what part B is. This is the majority of the marks for the question. So part A would be some working taken away from 2 pi, that sort of thing, and then an answer mark. Find the total perimeter of the earring. So total perimeter, we're talking from X to Y, from Y to Z, from Z back to X. So we're talking about all of those 3 things. Right, let's work out the YZ bit first. Okay, so YZ is an arc length. Formula R theta. What's my R? 5. What's my theta? 1.1. So 5.5 millimeters. Nice and easy, that bit. Right, what's the other thing we need to find? We need to find the length XZ, same as the length XY. So let's have a look at what we've been given there. If I was to draw that out as a little triangle, it looks like that, and like that. So that length there's 15. This angle here, okay, is my 2.59. This length here is 5. And I want to find out this length here, XZ. Now, different to the previous question, this isn't an isosceles triangle, so I can't do my usual splitting it down the middle. So for this particular one, I am going to have to use the cosine rule. Now remember, you need to learn the cosine rule, but remember what it is. Okay, so the length I'm finding squared is the sum of the squares of the sides that make the angle minus 2 times the side lengths and then cos of the angle between them, which we worked out as 2.59 there. Okay. All right, so I've left that 2.59 in my calculator, so I can put in the exact value. So I'm going to type in 15 squared plus 15 squared minus 2 times 15 times 5, cos of that answer. And that gives me 377.87 ... Okay, so I've left all of that in my calculator. Now, common mistake with cosine rule, you forget to square root. But really, when you look at in the context of the question, 377 would be a silly answer for that length. It would be far too long. So that should hopefully indicate to you that you've forgotten to square root. So that is going to be the square root. I've written 19.4, but I've left it in my calculator. Right, what's the question asking for? Total perimeter. So total perimeter is given by the arc length YZ, which is 5.5. So that's your YZ. Okay, plus 2 lots of my 19.4. Okay, so that is my XZ and my XY, because they're the same length. So 19.4, I'm using the whole answer, I'm sticking it in my calculator, I get 44.3 something or other. Now here's where you go back and read the question again. This is really important, okay? This is such an easy way to throw a mark away in a question by not giving the answer to the specified accuracy. A lot of you have done that on some homeworks that I've marked, particularly the homework assignment. Okay, nearest millimetre, that's going to be 44. Okay, and that's to my nearest millimetre. Okay. Right, lovely. So that's about arc length. All right, so what I'm going to do is get you to complete all of these questions, please. Some of them are a bit tricky, okay, but I would like you, please, to submit these via Teams. Okay, so and by the end of Thursday, and so I can mark those and have a look at those, please. Just checking what the date is for this lesson that you'll be watching. So you should be watching this on Tuesday 12th of May. So I would like that done by end of Thursday the 14th of May, please. You're all getting pretty good now at taking pictures and uploading them. Either upload the image or cut and paste it into the document is preferable if you can manage that. Lovely. So if there's anything you're not sure about, please go back and watch it again. Make sure you've got all of those written down in your notes though, please. Calculators in Radians mode, showing all of your working. Okay, remembering your units. Right, thank you very much.